Ladies and gentlemen, welcome to this audio slides presentation. I'm Mingying Zhang. For the next 5 minutes, I will discuss our recent paper titled Perception-Based Model Simplification for Motion Blur Rendering, published in Graphic Models. Motion blur effects are very important to motion perception, which are required in visual arts, interactive games, and animation applications. Usually, such motion blur rendering is quite time-consuming, so blocking online and interactive use of effects. Till now, some psychological studies have revealed that theory that motion blur effects will hide detailed features, by which motion blur effects can be rendered with simplified models. However, with a theoretical basis, no technique is proposed for how to generate the simplified models for the purpose of motion blur rendering. In this paper, we propose an efficient approach of using simplified models to speed up the motion blur rendering, which can be easily integrated with various rendering techniques. To guarantee the rendering quality as using the original model, we mainly work on two issues with respect to moving objects. We first developed novel algorithms to simplify models with motion-aware rendering, trying to preserve the features whose variation is not parallel to the moving direction. Then, we deduced the formula to get a simple level of details for model simplification by the object's moving velocity. First, let's talk about how to preserve the perceptive features in motion blur effects. For each pixel's illumination intensity, we integrate the illumination of its corresponding trajectory on the moving object. As a result, the features on the trajectory will be hard to distinguish for human beings. For the neighboring features on different trajectories which are in parallel, the related lights are not integrated for rendering blur effects, so they should not be considered together for simplification, as shown the 2 pixels here. For our direction-aware simplification, a weight is added to the cost of every edge, trying to earlier contrast edges which are more parallel to the moving direction, as marked in yellow, because the features with such edges are more possible to have their variations parallel to the moving direction. As a result, triangles in strips in direction of movement are first contracted, so the features parallel to the moving direction can be well preserved. Second, let's talk about how to get suitable level of details for model simplification. To simplify the geometric objects for motion blur rendering, we should know the sensitivity of the human visual system to the features in viewing the moving object. The vision scientists have studied this effect by measuring the threshold contrast for viewing traveling sine waves, in which it uses the velocity of the target stimulus with respect to the retina and derived a contrast sensitivity function, CSF, for the sensitivity of measurements. Curves by the CSF function with different retina velocities are plotted. By these curves, we can know the frequency ranges of features that can be perceptible under retina velocity. For example, according to the curve VR equals 3 degrees per second, the features with their spatial frequencies below I2 can be perceptible, though they have different sensitivities. Therefore, we deduce the relationship between the velocity and frequency of features that should be preserved with respect to retina velocity. We made a user study to investigate the effectiveness of using this revealed relationship to guide model simplification. Here we show the quality comparison among rendering results with original models at the ground truth, our simplified models and the simplified models without considering the effect of motion direction. Obviously, rendering quality with our simplified models is very close to the ground truth and much better than the simplified models without motion aware, for features whose variation is not parallel to the moving directions are well preserved in the motion blur effects. We have incorporated our perception-based method with different renders to test the effectiveness using our approach to speed up motion blur rendering. It is more obvious for our simplified models to speed up rasterization-based methods. Thanks for your attention.